Hi, this is Dr. John Bergduff. In this video, I'm going to show you a few more constructions that you can create using a compass, a ruler, and a pencil. This is the second of my videos on this topic. I started with some very basic constructions in the other video, and I have three more that I'd like to show you today. I'm actually in this video going to invest in a slightly nicer compass. These compasses like this one you see right here that you can get pretty much anywhere at a store for just a few dollars are fine, except they do have a tendency to slip, and the pencil has a tendency to slip. On many constructions, it's not enough to make much of a difference, but on one of the ones I'm going to do in this video, you can get off by a good deal. So I am going to switch out this compass for this much fancier compass over here that works exactly the same way. So let's look at the constructions we want to do. The first construction that we want to do today is to create a parallel line. Construct a line parallel to the given line, but passing through the given point. A line parallel to this line passing through that point. There are actually several ways that this can be done. The way I'm going to show you is we're going to basically create a rhombus. A rhombus, you'll remember, is a quadrilateral with four congruent sides. The measures of the four sides, the lengths of the four sides are the same. So if we can create those same length sides, we'll create a rhombus. Why do we care? The reason we care is that opposite sides of a rhombus are parallel to each other. So if you create the rhombus, you end up with the parallel side that you can extend into a line. So to create side number one of my rhombus, I need to just have a line segment that joins that point to this line. You can do that at a right angle and actually end up with a square, but the constructions can be a little bit hard to manage. You're actually better off if you take your line and you put it at some other angle. All that matters, and this is totally random, I just need to draw something that will go through this point and this line, and I'll draw something like that. And there we go, plain and simple like that. Now what I'm going to do is I'm going to create some sides of the same length. To do that, this side here is going to be one side of my rhombus, so I need to measure that length. Put the pointy end of your compass where the two line segments meet, and then adjust the pencil, which here you do with this little dial, until the pencil crosses right there at that other point. Let me be even more perfect. As if I'm ever perfect. Go right through there and make an arc. So make sure this is sitting right where that is, and draw an arc right through there like so. In fact, let's go all the way down and cross both lines like that. Now, where this arc crosses this horizontal line, because that circle has a constant radius, the length of this side is equal to the length of that side. That's two sides of your rhombus already. To get the third and fourth side, do this. Take the pointy end of your compass. Don't change the position of the pencil. That's very important because you want the lengths to stay the same. Draw an arc out here, kind of in the space, so it looks like it's going to be somewhere between the two sides of the angle I've drawn first, putting the sharp pointy end there, and then putting the pointy end right here at the other crossing point. Where these two arcs cross, you're at both the same distance from this point as you are from this point, and that therefore creates a rhombus. So what we will do is we'll draw line, and actually this is all we're really going to need, that passes through that original point and the point where these two arcs cross, like so. That line is indeed parallel to this line, and if you'd like to see the entire rhombus, that's created by looking at the point where your original arc crossed the horizontal line and this final crossing point again. And I'll just draw that in. That's not required for this question, but you'll see the rhombus created. More importantly, the parallel side. That's number one. In the second construction, I want to create a parallelogram. And you might say, well, hey, a rhombus is a parallelogram. Let's just do another one of those. But this one is a little bit more specific. I want to draw a parallelogram using the given angle and with sides intersecting at these two given points, here and here. And I think you can see pretty obviously that this length would be different from that length. So I'm not going to end up with a rhombus, but it will still be a parallelogram. To create this, I'm going to make congruent copies of angles. I'm going to look at this angle formed by these two sides and essentially recreate that same angle with its vertex here and then with its vertex there. If I do that, I will end up with parallel sides. Let's talk about how you do that. So for this construction, it is not necessary that you keep the pencil right where this point is. In fact, it may be slightly messy if you do. So keep the pointy end where the two sides of the angle meet. Bring the pencil in a little bit, like that, and draw an arc so it crosses both sides of this angle. Now, this is incredibly important. I want to draw a similar line, a congruent arc with its vertex both here and here, here. Well, let me get where you can see it, here and here. And so I want to keep the position of my compass exactly the same. Put the pointy end right there at that point. Draw another arc out this way. Using that as the vertex. And then draw another arc using this as the vertex right here, out this way. Now that in and of itself does not create an angle, but here's how we can recreate that angle. To get how spread apart the angle is, go back to the very first arc you drew, and now you're going to have to adjust your compass. I want to put the pointy end where that original arc crossed the opposite side, and then move the pencil so that it lines up and hits exactly where the line crosses the far end of that arc. And I can make a little mark here just so I can see that I really have hit that point, as you can see. Then what I will need to do is I need to look at where this arc crosses this side and measure down the same direction. I do see a slight problem here that's easy to fix. The arc I drew, the line didn't go far enough. I can extend that by just taking my ruler and carefully lining it up so it extends farther out, like that maybe. Go to this crossing point and draw an arc downward so it hits this new arc, like that. And if I join this point to the point where these cross, like that, I will have recreated a congruent copy of that angle. And you can already see pretty well that this line and this line are going to be parallel, and that's perfect. We just need to get the other side. Well, how do we do that one? Well, I want the same angle, but with this at the vertex. I can't measure down from a line this time, but I can measure up. So I look at the first arc that I drew with that as its center, not changing where the pencil is any, because I want all three of these angles to look alike. Put the pointy end, unfortunately, I don't really have to extend this one, but put the pointy end where the arc crosses that original horizontal line. Draw another arc. If you're worried about whether that arc should have crossed this line here, don't be worried. We're creating this side of the parallelogram now. So what matters is that we can draw a line segment joining this point to that crossing point. And that will be a parallelogram because we've made all these angles congruent. So if I join the crossing point to that final point, and I think you can already see it, you're going to have a parallel side. And the four-sided object, the quadrilateral you end up with, is your parallelogram. So that's pretty cool. One more construction, and this is the one where a really weak compass that wiggles a lot is going to give you trouble. We want to inscribe a circle inside this triangle. In the last video, you might remember that I circumscribed a circle around the triangle. Something would go outside the triangle and hit all the vertices. This time I'm going to draw a circle inside the triangle to hit all the sides. And the technique I'll use is a little bit different. What I really need to do is to bisect all the interior angles. I'm going to alter that statement slightly in a minute. If I bisect all the interior angles, the point of intersection becomes the center of a circle that inscribes the triangle. Now, you can sort of imagine this. If you drew a line segment that cut this angle exactly in half, and also this angle, and also this angle, you can at least imagine that they would hit somewhere in the center at a point that could be a center for a circle that would hit all three sides. Now, the fact of the matter is, to determine that crossing point, you really only need to bisect two angles. The third one, if you draw it in, should cross at the same point. But just to make it easy on us, let's change the word all to the number 2, and we're going to bisect two interior angles. We actually have bisected angles before, you might remember, but on the previous video, but we're going to do it here too. We just need to pick two vertex angles. Maybe I'll start with this one down here. I'm going to put the pointy end of my compass right at that corner of the triangle. It's not terribly essential precisely how wide you make your pencil this time. If it's too small, it's hard to draw. If it's too big, you risk going off the edge of the triangle. So just somewhere, a little bit longer than halfway across that side. And I'm going to make a mark right here where it crosses this side of the triangle, and another mark or arc where it crosses this side. I'm looking at the points where that arc crosses here and here. Now, for the next step, you don't necessarily have to have the same positioning of the pencil for this one. You can change it, but actually it's probably just a whole lot easier if you leave it alone. Locate the sharp end, the pointy end, where the arc you just drew crosses one side of the triangle, and draw another arc out here, somewhere where you can see that it's going basically through the middle of that angle. That was drawn from this crossing point. Now we'll draw another one with the pointy side at that crossing point. And where these cross, right there, if I draw the line segment from that vertex through that point, you can see how good this is. It will bisect that angle. And let me just do that as carefully as I can. Like that. Let's bisect another angle. Same process, pick another angle for no particular reason. I'm going to pick the one on the top. Again, no particular reason. I would like to put my pointy end there. It is not necessary to use the same length, but it's just a whole lot easier if you keep the length the same, just consistently all the way through. You will cross this side of the triangle, and you'll also cross this side. can see there gets to be a lot to keep track of. I'm going to put points where those two arcs I just created hit the triangle to sort of remind myself those are the important ones. And now to bisect this angle, again, don't move anything, leave it the way it is. Locate your pointy end at this point where the newest arc crosses this side, and draw an arc out here someplace. And similarly, put the pointy end at this point and draw an arc someplace. These two arcs will cross. Got to keep track actually of which two arcs you just drew. It's these two arcs, this one and this one. So the crossing point I'm looking for is right there. And it should be the case that if I draw a line segment from that vertex to that point, it will bisect that angle exactly. Looks pretty good to me. So let me draw that in. You can see that these two cross. And I think you could at least imagine that if I did the same process and bisected this angle, you could see it would probably cross it right about what it should be, exactly at the same point. That point can become the center of your circle that inscribes the triangle. To get the circle, here's what you do. Go ahead and put the pointy end of your compass right where those two lines cross. And if you then adjust the pencil so that it just hits, let's say, this right side of the triangle, like right there. Looks like it would cross right at that point. If I go over to the other sides of the triangle, it will also hit those points, at least as close as within humanly possible. And I think it looks pretty good. Maybe I'll come in just a tiny bit. If I draw a circle with that as its center, all the way around, that's looking really good. It will hit all three sides of that triangle. Just kind of go around a couple times to make it really dark so you can see it good. That circle inscribes the triangle. This one, when you're showing it to other people, can be frustrating because it has to be pretty precise to look good. If the compass moves any, it can be off by a little bit. Anyway, I hope you will enjoy those constructions along with the ones I showed you before. And there you go for compass, straight edge, and pencil constructions.